valid, ready, address, W data. Oh, so this is the one problem. There is extra one more end module was there. Okay, let us compile this program. Now you analyze this output. Okay, there are two end modules was there. That is what I was getting error. Now you can see the output to this. So what we are doing in this case is, what is the reset we are making out to? This is the rising edge of the clock, correct? And then this is another rising edge of the clock. So we are making reset up to what? At the time 20. So in that case, what is my read enable, write enable? Let us keep this integer I here. We want clock, reset, read and write enable. Then what we need? Valid. Then what I need to keep here? After valid, I am going to keep the read. Then this is W data. Let us keep the W data below. Let us make this address into unsigned integer. Whatever the values here it is showing here, it is in binary format, right? 00000001. So I am going to keep. How to keep this in unsigned format is right click on that signal. Okay. Then you will be getting this option menu. You will get here. Go to the radix. You keep this into hexadecimal, decimal, octal, binary, whichever the format you want to keep. I'm going to keep this into the what? Unsigned format. Then here W data I'm going to keep it as hexadecimal format. Is it fine? Hexadecimal format. How many decimal digit for this width? W width is nothing but 60. You need a 4 digits, correct? So here what happens? At this stage we are making what? This set to low. So by default we are making what? Read enable, valid is 0, and ready we are making 1. Correct? When reset is equal to 1, go to my design file. Let us open the design file. What we are doing when reset is equal to 1, our data is equal to 0. First let us take our data is 0. When reset is equal to 1, our data is 0. This is my R data. Let us make this is also into hexadecimal form. Our data is 0. Then what I am doing is, when my reset is equal to 1, ready is nothing but 1, 0. Is my ready is 0 here? This is a ready signal is 0. By default others will be what? Unknown. It will take X value. Then when my reset goes low at what the time? Time t is 20. But in my program I am writing what? Always whenever it comes to the positive edge of the clock. When this pause edge comes, what is my reset is? 0. What is my this is signal is for what? WR enable is nothing but what? 1. And what is this is nothing but valid. And then it will wait here, and this read will makes what? 1 in this one. So to do handshaking, we should wait some time, right? So that this is happening here. Ready becomes happening at 1 year. Now we are writing the data to this. Correct? This is the data we are writing. 3524 again for up to how many cycles we should write this is. We should write. So this is printing only. Let us do this. This is printing only 100 picoseconds, because since my simulation time, finish time, what time I am giving here, it is only 100. Let us make this into what? Let us make 1000. Okay. I am going to save all. Now let us compile it. Now I am increasing the what time? Simulation time. Finish time I am increasing here. Now let us see this. Now write is happening here. So let us zoom this. Let us make. Let us keep this I here. Reset enable. Then I keep the ready after the valid. then this is my address. Let us make the address into what? Address into unsigned. Then shall I make the W data into what? Hexadecimal. Then I'm going to make the read data into also hexadecimal. Okay. Now I think you are understanding it. Here my ready is 1, valid is 1, WR enable is 1, reset is 0. Now what I need to do? I need to write the data. Write the data to the memory. So writing the memory for what? What is the width of this is nothing but. For what is the loop? It is start from 0 to 31. Correct. Depth is nothing but what? 31. Up to 31 it is writing the data here. We are writing the data. After 31 what we are doing? We are making reset is 0. What we are making here? What is this signal is nothing but write enable is equal to 0. Then what is this nothing but valid is equal to 0. Ready is equal to 0. Then address we are making what? 0. Then W data is making what? 0. This is nothing but what? What is this? Nothing but we are writing the data in the what? Memory. So you can go here memory list. Still this is a memory list. Let us see this. Let us change the property this into the hexadecimal. Right click, change the property. So this is a memory writing. It is printing in reverse order. What is the first location memory is nothing but 3524. Second one is what is the best first memory location was what? 3524. Second location is 5281. Sorry, 5E81. Next is D609. So on. Now where you can see this memory list is nothing but go to this memory list. Here you can double click on it. So it will by default it is printing in binary. To change that property you right click, go to the property, make this into what? Hexadecimal. So we are writing this data into the what memory. Total what is the width it is? Well, what is the width is nothing but depth is 32. Width is nothing but what? 16. Did you understand? Now we understand that how to write the data. How to write the data to the what? Memory. This is clear up to here? Now we'll see that how to read the data. How to read the data. To read the data, what I'm going to do, let us go with the task. What is the use of the task? Reusability, code reusability. I'll be using the same here. I'll be using this. I'm going to write a task, one task for the write, one task for the what? Read the data. Shall I go for the task now? Because of the code reusability, I don't want to write again and again this for the read data. So I'm going to what? I'm going to write a task. So this is a task I can write. For this is for what? What we are writing here. This for what? Writing the data, right? Write the data. We are writing the write the data for logic is this is the one. Now what I am going to do? Shall I make a task to this? Task. The task name I am going to use. Let us write underscore what? Memory. Memory. Task with no inputs. 0 inputs, right? It should be 0 inputs and any input arguments. Now what I am going to do? Next what I need to do? Begin and end, correct? Then what I need to do here? I need to end the here. This is the end for end the task. I am writing task here. Correct. This is the end for what? This begin. Then what I need to do? End the task. End the task. Now I need to end this initial begin here. Correct. Now I am going to end this. Now I created the task. Correct. I have created the task. This is the one. This is the creation of task for what? Write memory. I have not called anywhere this task. If I run this program, whether write data will happen, write data will happen. I am not calling anywhere this task. So by default, I will get what? Write data is equal to what? 0. Write data is equal to 0. Let us show this transcript. Here we are monitoring all the values here. Already we understand by looking at the timing diagram, right? Here I am monitoring the time, clock, reset, read enable, read write enable valid ready address and the W data. So W data is unknown up to this clock cycle. So at this clock cycle, what happens when the clock is high, enable is equal to 1, valid is equal to 1, ready is equal to 1, then it is start reading the data. You don't understand this. Is it clear this? Now in this program, I have created the task here. Task for what? Write the data. But I have not called this program. If I run this program, whether I will be getting the output for this? No, right? I have written the task, but I didn't call anywhere. So I am getting what? All my write data to what? X only, unknown. It will take by default, what is X value is nothing but unknown. Now you can see all W data is taking what? X. One address also taking what? X. Since I have not called this, right? I have not called this, so that I am getting all this what? X. According to my design, this is nothing but R data is I am getting what? When reset is equal to 0, I am getting R data to 1, 0. This is clear? Now how to call this task? I need to call this task. How to call this task? This is a task we have created for what? Write the memory. Then I can call the task here. After the reset is equal to 0, I am going to call the task. How to call the task? Task name. What is the name of the task is? Write underscore what? Memory. Here I am calling the task. What is the use of the task? You know that this is for the code reusability. Now in this place, what it is going to call? It is going to call this, correct? Did you understand this? Now let us save and run this code. So we will be getting the same output, correct? What we are getting earlier, without task what we are writing, I will be getting the same output here. Are you understanding this? Now we are writing the data here, you can see. We are writing the data. Let us go and check this waveform. So we are writing the data here. Let us keep this address to unsigned. Let us keep W data to hexadecimal. Now we are writing the data. You don't understand this. This is the data. This is nothing but address. What is the address width is nothing but address 0 to 31, right? Address width is 5, but the depth, what is the depth is nothing but 0 to 31. Up to 31 it is going to write the data. After that we are making what? All these are making it to what? Zeros. You don't understand this. Now we understand that how to write the data. Now what I need to do in the next step? Now I need to read the data. How to read the data? Shall I use the same task here? To read the data, I am going to use the same task. Let us copy this. Now I will modify this task code. So let us copy this here. Now this is the task name what I can do. Read the data. Read the data. Then what are the changes I want to do in this code? This is for writing the data. For the read from the memory, what I need to do? Again, for I to 0, I is less than depth, I plus begin. Then always at the what? I'm looking at positive edge of the clock. Then what I need to do? Address of all the address locations. Then whether I need this W data? No, right? I'll remove this. I'm going to remove this. W data is not required. Now my intention is what? Read the data from the memory. Then what I need to do is write read enable to what? 0. When write read enable is equal to 0, then what I need to do? Read the data. Then valid is equal to 1. Write ready is equal to 1. Then this is saying after this loop, I'm doing what? Address is equal to 0. Then you can make what? W data to 0 or R data to 0. Then enable is equal to what? 0. Valid is equal to 0. Let it be saying what? After completion of the what? For. Did you understand? Is it clear? Now we have created the task for what? Read the data. Now I need to call this task. Shall I call the task here? After reading the memory, correct? Then I am going to call this task read underscore memory. Read underscore memory. Now I am going to monitor what? Read also. After W data, now I am going to what I need to monitor? Read data. Our data is equal to, let us print this in the hexadecimal line. Now what argument I need to pass here? Then I need to pass the argument is R data. R data. Did you understand? Now let us save all. Let us compile this code. Now we are reading the data here. You can see this is R data, this is W data. So, after 32, okay, you're saying that you make this R data after 32, after the iteration of this, you are saying that you make R data to 0. Let it be what is there. My intention is that throughout this depth, whatever depth is there, I want to read that data. After this also, I can make what? W data is equal to 0. There is no problem, right? Huh? Now this is what we are reading the data here. Let us go here. So 0 to 31, we are reading the data. 0 to up to year 31, what we are doing? We are reading the data. Then what we are doing after this? We are making W data to what? 0. It will wait for the few clocks. Then again what happens here? R data is happening, reading the data from the memory is happening here. Let us show the waveforms here. So let us keep this I top, clock reset enable valid. Then I am going to keep ready. Then this is my R, keep the address. Make this address into the unsigned integer. Then keep the W data into 1 hexadecimal. Okay. Keep the R data into 1 hexadecimal. You can understand? Now write data is happening from where to where? 0 to 31. 0 to 31, so this is address. Write data is happening. And after this, what we are doing? We are making the write data to 0 after this. Now again, here what happens here? It is ready with here. Ready became 0 and ready becomes white. At this positive edge of the clock, what happens here? Reset is 0. This is nothing but, this is a reset. This is nothing but what? Write enable is equal to 0. Write read enable is equal to 0. Then valid is equal to 1. Then what happens here? This is nothing but ready. Ready is equal to what? 1. Once this is ready, we are reading the what? Read the data from what? Memory. So it is delayed here. So this is reading the data from here. 3524. Again what? Same data I am reading here. So up to where? Up to 31. So after 31, what happens here? After 31, we are making W data is what? 0, 1. Now read data, write data is happening here. If I go and check the memory list, this is my memory list. This is a memory, we are writing to the memory and then we are reading the memory. So I can easily do using the task, right? Code reusability. I don't want to write again and again. I'll write it. So whenever it is necessary for me, I'm going to what? Call the task. We don't understand this, how to read the memory and how to write the memory. Is it clear? See, basically if you are understanding, to understand the projects of very large, if you are understanding memory modeling, like upcoming projects like FIFO, like synchronous, asynchronous FIFO, other programs became easy. Those are purely depending upon memory concept. Almost if you are well and good understanding about how to read the data, how to read the data, how to understand this, how to analyze the timing diagram of read data, write data, memory modeling, now this becomes easy. Is it clear? Now we have done the read data and the write data. Now let us, so this is what is the depth we are using for this is nothing but width is 16, depth is 32. Now what is address size it will be? Address width will be 5. Correct. Now how to overriding the parameter? I want to model the different width and different depth. What I want to do? What I want to do? What I can to do during the instantiation, I can do what? Parameter overriding. I can override the parameter. So what are the parameter I need to override? Suppose I want to make, this is my test bench, right? I want to make, this is width is 16. So depth is, let us make depth also 16. Depth also 16. Okay. Now let us make width 8. Okay, nothing to worry. Width is 8 and depth is what? 16. Then what is address width will be? 4. 16 means what is address width is what is 4. You got the point? Now how to overriding the parameter to this? So, okay, let us do one thing. I am going to take one more file. Let us take wtb2.v file. Okay, so how many files are saved? Only one test bench, right? Okay, let us make this is tb1.v file. So in this case, what we are going to do is nothing but we are going to overriding the parameters. So tb1.v file. Design file is same. Now I need to override the parameter. What is the width I am giving is 8. What is the depth is 60. Now I need to override the parameter. How to override the parameter? As correct dot width of width comma, then what I need to do? Dot depth of depth dot depth of depth. Now I am overriding the parameter. In my design file, what is the width is 60. What is the depth is 32. Now using CLog2, we are calculating the depth. Now what is how it is modeling the memory here? How here it is writing the memory and how it is reading the memory. What is the size of the address width is 4. How many bits we are keeping in the memory? What is the width of the memory is 8 bits. 8 bit means in the digit, how many digits? 2 digits. Correct? Let us save this program. Save all. Now in my run.do file, what I need to do? The run.do file, I should change this into what? tb1.v file. Now let us compile this program. Now we are doing overriding the parameter. Now what is the width of this is nothing but 2. Correct? So we are overriding the parameter. Now what is the address width is nothing but how many bits now? Address width. Let us keep this is top. Sorry. Let us keep this a reset below this. And this is, I am going to keep it top. This is enable valid. Keep the ready here. This is the address. This is the W data. This is the read data. Now this is my, I am keeping the address into the unsigned. Keep the W data into what? Let us keep this in the hexadecimal. R data I am going to keep into the what? Hexadecimal. Now what is the data? How many bits memory modeling we are doing? 8 width is 8. Depth is what? 16. 16 means 0 to 16 what? What happens here? 0 to 15 means read should happen. After that, what it should happen? I am writing what? Read should happen. Now if you go and check the memory list, so depth is what? 16. Width is nothing but what? 8. Now this is the memory. In the location, memory locations. Are you understanding this? Now depth is 16, width is 8. Now we are overriding this parameter. We are overriding the parameter. Did you understand? Now I'll ask you the question. I want to do different test benches to understand how to model the memory. I want to make only the particular range. I want to write the data to, suppose what is the depth of this is nothing but 0 to 15, means 16. Now I write should happen only to the 10 to 50. 10 to 50. Read also I should make what? 10 to 50. Let us not. How to do that? See here what happens, right should be happen from what? For this loop, right? Loop is what? 0 to, in this case, what is the depth is 16. 0 to 15, we right is happening. Read is also happening what? 0 to 15. Correct. Now what I want to do, I want to do the right operation from the 10 to 15. Instead of 0 to 15, I want to write only one. 10 to 15. And read also you can take from the what? 10 to 15. How to do this? Did you understand the question? What I am saying is, here read and write is happening from what? 0 to 15. Based upon the depth. Read is also happening from what? 0 to 15. I want to write only the particular range. Let us take 5 to 10, I want to write the data. 5 to 10, I want to write the data. Then if I am reading, I need to read 5 to 10. How to do this?
Add if condition. So if address ADR equal to 5.
If address ADR is equal to 5, then we should write.
Yes, and also R operation of ADR equal to 10.
Okay, one way to, there are a couple of ways you can do this. Correct. What I am going to do, is it clear up to here? Are you understanding how to write the data and how to read the data? What the program we are writing, what the task we are writing, what is the use of the task in particular example. Correct. Now let us go with the particular range I want. Particular range I want. What we can do, you can pass the argument to the task. You can pass the argument to the task. So this is the right data. So I'm going to use task is input variable. Let us make this is address underscore with -1 colon to 0. What is the range it is going to take? What is address width it is going to take? Address width is nothing but what here? Here depth is 16. Let us take 16. What is address width is nothing but 3 down to 0. 3 down to 0. So let us take the variable as start location. Start location. This is a one variable. Now I am going to take one more input argument. Input. So this is address. Address underscore width colon to 0. You can understand? Then what I am going to do, let us take this as like a num location. Num location. And these are two arguments we are using. Okay. And similarly for what? Read data also I am going to use this. Now input, what we are using is address underscore width -1 colon to 0. This is nothing but what? Start underscore location. Start underscore location, then what? Input. I am using what? ADDR underscore width colon 0. Then I am going to take this as what? Num underscore location. Did you understand this? Now in my for loop, what I said, I want to take the particular range 10 to 15 or 2 to 10, 2 to 14, 7 to 14. I want to write the data and what? Read the data. So how to iterate the loop here? Okay, iterate the loop. How many arguments we are using for the task is? 2 arguments. What is the one argument input is nothing but start underscore location. Another input argument is nothing but what? Num underscore location. Shall I start for this? Start underscore location. I is changing from where to where? Starting at what? This is my starter. Starting the for loop. Start underscore location. Then what is the depth I should keep here? Particular range I want. Correct. Shall I make this is start underscore location plus number underscore location like this. Suppose you start location, I'm giving as 10. Number location, I'm giving as what? 15. Argument passing to the what? Task. 10 and 15. What is my start is? Start at what? 10. What is the loop condition to this is nothing but start is 10 and num location is 15. Let us consider. Start location is 10, num location is 15. For what iteration it will do? This is start location is 10 plus 15 means what? 25. This condition will satisfy from where to where? 10 to 25. If I am using num location here, start at 10, condition is up to 15. You don't understand this. Are you clear this? Now I is getting incremented. Similarly, for your write data also, write data, you can change this I to what? Start underscore what? Location. Then this depth what I can do? The depth. Let us make start underscore location plus what I can do? Num underscore location. Num underscore location. If start location is 10, num location is 15, what is the range it is taking? I will start at 10, n will at what? 25. I am using now start location plus end location. I am doing addition. I am doing so that I can take the only particular range of the address. Is it clear? Now what is the argument I need to pass when I am calling the task? What is the argument I need to pass? What is the argument I need to pass here? Two arguments I am using to the task, right? Shall I pass? Let us pass 0, depth. What is depth is? 60 in this case. I am overriding the parameter 60. Here also I am going to pass the two arguments. Depth here also then shall I pass 0, depth. Now what is my start location is? 0. Correct. What is my end location is nothing but 16. This becomes what? The start location is what? 0 plus 16. Correct. It will take the range from where to where? 0 to 16 in this case. Now I will be getting the same output what I am getting in the correct for this argument which I am passing to the task. You understand? This will be the same. Let us save this file. Save all. Now let us run this. Now you can see this happened from where to where? 0 to address is 0 to what? 15. Because depth I am giving, I am passing the argument, this is nothing but what? This is write data is happening. After that what happened? Read data is happening. Now what I am going to do, I will be going to change the depth. Let us make a depth divided by 2 means what? 8. Okay, let us first what I am going to do. This is the starter. Location is 0. Let us make end location is 10. Okay. Again, start location of this is nothing but 0. End location becomes what? 10. 0, 10, 0, 10. Now it is writing the data from where to where? 0 to 10 or 0 to 9. What is this num location is nothing but? What is start location is? This is nothing but address is nothing but 4. 3 down to 0. Now this becomes 1. This 4 minus 1 is nothing but 3. 3 down to 0. This becomes 1. Is it 4 down to? What is address here? It is nothing but 4. 4 down to 0. Now it will be taking the start location this time and then num location is nothing but 1. Then start location is 0 and num location is nothing but 1. Now read should happen from where to where? First let us take write. Write should happen from where to where? 0 to 10. Read also should happen from what? 0 to let us take this, save this, that is good. Now let us check this. Let us change address to the unsigned integer and change this W data into the hexadecimal form. Let us keep this here. Now it is writing address will be writing from where to where? 0 to 9 means what 10. Only this range will be what? 0 to 10 will be we are writing. Then we are reading what? From where to where? 0 to 9 means what? 10. So that I can write the data into what? Okay, let me show the memory list here. This is a width, depth is 16 and width is 8. Now we are writing from where to where? 0 to 1. This is 0, correct? 0 to 9 means what? Total 10 locations. Remaining are what? Zeros. Did you understand? Now let us make this 0 to 5. What happens in this case? 0 to 5. Only 5 locations will be what? Right and read will be on. Let us save this and run this one. Now let us see here from where to where it is happening. 0 to 5. Did you understand? What we did is nothing but for the task we are passing the 2 input arguments. So by passing this, I can write the only specific range. Are you understanding this one? Now we understand that how to write the data and how to read the data. Do you have any questions here regarding how to make I want